Assalamualaikum dan selamat kembali ke FTV. Okey, hari ni kita nak cerita pasal kereta elektrik ya. Dan cerita ni cerita besar lah, besar sangat cerita ni. So hari ni kalau awak nak dengar benda ni, awak kena faham. Hari ni kita akan banyak campur English dengan Malay because some of the things are just too technical untuk I nak translate quickly into Malay and try to explain this. So beberapa perkara telah berlaku dalam sehari dua ni pada hari Selasa ataupun Rabu pagi pukul 4.30 pagi di Malaysia, 1.30 pagi di Fremont, California, Tesla mengadakan dia punya perjumpaan tahunan dengan shareholder, annual general meeting dia dengan shareholders, and also dia ada dia punya battery day lah. Usually dia akan this has been a trend with Tesla. Last year dia orang buat dia orang punya autopilot atau full self-driving day, and now autonomous driving day. So now dia orang buat dia orang punya battery day lah. So battery day ni ialah di mana dia orang nak ceritakan ataupun those technology day tu, the AI day tu, sebenarnya dia ceritakan apa yang dia orang tengah usahakan, apa yang dia orang tengah bangunkan. So benda ni kita kena tengok from quite a different perspective daripada apa yang kita biasa tengok daripada syarikat-syarikat kereta yang lain, okay? Kerana kalau kita tengok syarikat-syarikat kereta yang lain, kebanyakan mereka tak akan cerita apa yang mereka akan buat dan akan actually deliver in the next 2 years lah, or next 2-3 years. Selalunya dia orang simpan and dia orang cerita pasal konsep, pasal benda yang so far out, and kita tak tahu bila benda tu boleh keluar lah. So you have all these concept cars yang pelik-pelik and all that, and cerita-cerita pasal benda teknologi yang jauh lagi. Jadi kenapa syarikat kereta buat macam tu? Senang aja cerita dia. Kalau you beritahu orang kata akan ada produk yang lebih bagus akan datang dalam masa 2 tahun, mungkin orang akan stop beli barang you sekarang. So kita kena cerita benda tu as something yang quite far away lah. Tapi Tesla ni pelik sikit pasal dia suka cerita macam seolah-olah benda tu dah nak sampai dah. Kan? Bila dia cakap tentang full self-driving, dia kata tunjuk dia punya new microchip design, microprocessor dia cerita dia macam benda tu dah dekat sangat dah lah. And it's quite confusing to some people when they look at it and they say, why is it like that? So here's what it is. Firstly, we have to look at what Tesla is lah. Satu, Tesla ni daripada awal lagi dia dah macam sort of offer dia punya teknologi to everybody. Siapa yang nak boleh datang jumpa Tesla and they will be willing to share dia punya teknologi. Probably for a price lah. I don't think it's going to be for free. They were not offering it for free. I don't know, maybe. But they have always been offering their technology for you to go and talk to them and use the technology if you want. So in that sense, that's what they have been doing. Kenapa Tesla begitu? For me, it's simple lah. Tesla does not see the rest of the auto industry as their new competitor. But the rest of the auto industry see Tesla as a threat. So, kenapa macam tu? Because Tesla tengah masuk ataupun membuka satu pasaran baru yang tak pernah wujud, iaitu pasaran kereta elektrik. So, Tesla is building a completely new market in the electric car business. So, this has never existed before, and therefore, for them, what they need is for a lot of people to get excited about electric cars. Yeah? So, bila dia nak dapatkan ramai orang excited pasal electric cars ni, dia kena dapatkan ramai orang buat electric cars. The example is like when you see Silicon Valley. Silicon Valley is only great because so many companies open up their shops there. And therefore you have a high concentration of really good and talented people doing tech, doing IT, doing technology. So you have a large pool and you keep attracting more and more people, you keep attracting more and more companies, so that becomes a center, and everybody talks about Silicon Valley as like a meme already for a center for attracting technology. So you have India, Silicon Valley, that sort of thing, so Malaysia, Silicon Valley, whatever you want to say, China, Silicon Valley. So it becomes like a meme. So Tesla wants to do that. So right now, at this point, they are almost already a meme lah. So when you think electric cars, most people akan nampak Tesla dulu dalam minda dia. So if you have any idea at all about electric cars, chances are you akan nampak Tesla. Even if you don't know anything about electric cars, then bila orang sebut electric car, you akan nampak Tesla lah for the most part. So they've been quite successful in that sense lah. And they've been doing it consistently because they know this is how they have to do it. So they've been very open about what they are doing, and in a way, it's for example, bila they show off dia punya AI ataupun full self-driving computer, and you look at it and say, and when you listen to the explanation during that day, they explain in quite great detail how they design the system and how they design the chip and sort of logic that goes into designing the chip, because they're looking at as a self-learning computer. That chip is a self-learning chip. So dia punya architecture dia has to be designed for self-learning punya protocols. And that is completely different from whatever else everybody else doing lah. Nvidia punya graphic accelerator ke apa ke. And it's a purely visual processing chip. Dia memang buat itu as a visual processing chip. So bila dia cakap benda-benda macam tu, memang it's revealing company secret. Tapi it's not really for Joe public. Pasal Joe public, bila kita tengok, kita tak boleh nak faham pun benda tu. And I say this because bila kita tengok dia punya AI day tu, the question yang keluar on that day is very basic. There is no really deep question that goes in, because that's not actually meant for us. Dia cakap tu nak cerita kat kita, tapi what it's meant for is actually the tech people in all the other industries. People in actual microprocessing industry, there are people actually make the chips, people in the auto industry, people in AI. They want to show off what they're doing because they want to talk to those people. Okay, for example, yang self-driving ni is, if you talk to AI people, they'll say that self-driving, if you solve a self-driving, you will solve all of the AI problems, because self-driving involves so much common sense. Untuk you bawa kereta requires so much common sense, requires so much motor ability, coordination, macam-macam benda. And therefore, it is the ultimate AI problem. So they're trying to show people that they are doing that, and telling to the tech people, the people in the AI industry, and you tengok, bila you tengok the tech podcast atau AI podcast, dia orang memang very impressed. But even when they explain, kita tak faham. But we know that they're very impressed with what is happening. So today, bila Tesla cerita tentang battery day ni, lepas cerita battery day ni, ramai orang expect macam-macam lah. Million kilometer, million mile battery yang whatever lah, macam-macam lah dia punya expectation. And some people feel disappointed with what was explained by Elon Musk on stage. But what actually he was doing was hiding everything in plain sight. So if you're looking at whatever he was saying on the battery day tu, there's several big numbers that you kena tahu lah. So bila kita tengok the final analysis, if you want to remember anything, this is the sort of thing yang kena remember lah. The new battery technology ataupun battery construction method, or whatever you want to call it, is going to achieve a range increase of 54% total. You campur everything, is going to be 54%. And more importantly, there is a cost reduction of 56% in terms of the kilowatt hour cost per kilowatt hour lah. So right now, everybody is looking at, I think masa Tesla baru start buat kereta, maybe it's about $180 US dollars per kilowatt hour. Then by the time they started doing the Model 3, it was maybe around 120. But now when they come up with the Model Y, some of the industry analysts kata dia orang punya cost per kilowatt hour, I think it's at the pack level, is 108 dollars per kilowatt hour. So a 56% reduction would bring it well below $100 per kilowatt hour. So this, we're looking at maybe $50 to $60 per kilowatt hour, and that is a major number, and we'll get into the discussion about that lah. And also something that is even more important is the investment per gigawatt hour. So they want to boleh reduce the cost of actually building this by 69%. That's a massive number. And there's so many things that they've explained macam mana dia untuk achieve that. So if you need to remember anything about Tesla punya battery day, that these numbers are actually fantastic. So we'll look at the basic first before we go into the technical details. So what does it mean? 54% increase in range. So let's imagine that sekarang the current Tesla Model S, yang biggest battery pack, and Model 3 pun, yang all the big battery pack cars, they're doing about 400 miles. So if you increase that by 50%, senang cerita, we increase 50% lah. You increase another 200 miles in range. That means it's 600 miles in range. It's like 600 lebih sikit lah, because it's 54%. 620 miles probably in range. 620 miles is 1,000 kilometer. So whatever it is that they're doing right now, once this goes into production, and we'll talk about whether it will actually go into production or not, their cars will, it looks like it will have a range. If either they give the full range increase to 1,000 kilometers, ataupun they reduce the battery pack size and make the cars cheaper, or either that, they reduce the battery pack size, offer the same range and have more margin to dump into whatever in the future, or just make more profit lah. In terms of the kilowatt hour cost reduction ni pula, again, that's a link lah, obviously kan. So the price of the cars will go down because they're now thinking of building the $25,000 car. So that could be the Tesla 2, whatever they're going to call it. Right now, the cheapest Tesla is about $35,000, and that's going to go down to about $25,000. So that's going to make it far more affordable and far more exciting for a lot of people. Because a lot of people, myself included, basically I've decided that the next car I want to buy is an electric car. Right now, the only thing that seems to be available to me is the Renault Zoe, but the Renault Zoe is not practical because it's too small and the range is quite limited. So I'm still hoping for a 400 kilometer, 500 kilometer range car that is affordable. That means below 150,000 ringgit. So if it gets around 120,000 ringgit and it's got 400-500 kilometers range, and I'm in the business already. That's what I want to buy already. So, but all we're looking at this in terms of Tesla punya interest. So all this has a bearing into the future, into what Tesla is. Okay, so now let's go back to what is it that they're doing with all this thing. So firstly, we have to go back again to how Tesla sees itself lah. So like I said just now, Tesla does not see the rest of the automotive industry as a threat to them, but the rest of the automotive industry see them as a threat. Kenapa? Because what I said just now, they want more people to build electric cars, so there'll be more demand for electric cars and move away from fossil fuel. Because that's been their statement of intent for the company as a whole. And that's why they're sharing their technology, they're offering their technology, because they want people to take up the technology and build electric cars. Like I said, they offer their own technology open for everybody else. So that's what it is. So right now, bila they're talking about this battery technology, some industry analysts kata it's strange that they're talking about this and like giving out trade secrets. And it's looking like maybe all this thing is just still pie in the sky. But I think the more important thing about this is that why Tesla is doing it is because they know what CATL is doing, CATL is doing, they know what Panasonic is doing, they know what LG Chem is doing, because they are probably the biggest customer to all these big battery suppliers, right? So they know what those companies are able to offer them. And by that, they will know what trajectory in terms of the chemistry, in terms of the production, in terms of whatever battery design that they are looking to, because they are basically in the same industry. And when you are in the same industry, you probably can tell what everybody else is doing. So when they're doing this, what they're doing is telling the other battery manufacturers that this is what we are working on, So if you're already working on this, fine, that's great. This is what our targets are, how we want to achieve them internally. Because Tesla tahu dia tak boleh buat semua bateri ni. There's just so much battery that needs to be built, dia tak boleh nak buat. So according to dia punya estimate pun, we probably need about 10 terawatts worth of battery a year if nak convert all the cars into electric. And that's just a lot. And they will need to all the other companies to be in the game lah. Then baru boleh ada critical mass to move the ICE cars just completely out of the way. So what they're looking at, firstly the battery design lah. So kita tengok the battery design tu is now a bigger battery. So instead of the 2170, which is 21mm diameter, 70mm height, sekarang is 4680. So 46mm wide and 80mm, 46mm diameter and 80mm in height. So this battery, kalau kita tengok some of the footages that they're showing, they're actually showing their own pilot production line. So when they're showing the pilot production line, for me it means that they've cracked the chemistry. They've cracked the actual structure of the battery, the actual design, the actual. So now where they're going, because Elon keeps saying this again and again and again, anybody can build a prototype, but we're going into manufacturing, mass manufacturing. That's the key. That's the problem. Where the problem is, and that's what they're doing right now. Actually, when they're talking this to this, in my mind, bila they tunjuk the pilot plant already, they've cracked already the battery technology. They've cracked the chemical, the chemistry, the whatever it is that they're doing, and then they're going into production. And right now, the company says that what it is they don't have repeatability yet in terms of dia punya kilang tu bila dia buat dekat the pilot plant. That means the failure rate is quite high lah. And the battery is still being produced, it's still going to look like the battery, but maybe the failure rate is high in terms of how much actually usable. So benda ni normal So because it's just a factor of complexity. So when you look at flat screen television sekarang, masa in the early days of flat screen production, when you look at screen sizes lah, yang kata for example lah, up to 17 to 19 in the early days lah, about 15 maybe 20 years 15 years ago 20 years ago, the failure rate was very high. It was maybe 70 to 80%. And it goes on the smaller screens, maybe up to 70%, maybe 60% in some of the better factories. But when you go to big screen, masa tu lah, I'm talking about 15, 20 years ago, when the big screen was 40 inches, the failure rate was over 90%. That's simple because the flat screen it involves individual units of diodes or whatever it is that makes it light up. So if satu fail, then the whole screen has to be thrown away. And they've got thousands and thousands and millions on every screen. So every screen has to be 100% perfect baru boleh jual. Kalau tidak, boleh buang aja lah. That's how it is. So that's factored into the cost. And that's why the cost of those flat screen was high initially, and now it has gone down because the success rate has been increased, and therefore they don't have to worry about that. And so what they're talking about right now is that it's not that they're not building the battery. The battery is already being built. The 4680 is already being built in the pilot plant. So now the success rate is low in terms of getting the battery out and performing as it should for automotive grade. Now you have to understand battery production ni, because when you look at the Panasonic punya battery production ke LG Chem ke CATL ke apa ke, these lithium-ion batteries has different levels of success rate in terms of what it is lah. So for an automotive grade battery, dia punya standard paling tinggi sekali pasal it requires high discharge and high charging rate, repeatability again and again and again. And dia punya failure tu has to be very low lah. So that battery is the best quality battery. Maybe you have like batteries in any factory, you have products that are grade A, B, C and D for whatever level lah nanti you have kan. So untuk grade A yang tu untuk automotive, untuk grade B and C maybe boleh pakai untuk static installation, untuk power wall, untuk grid batteries, stuff like that. So maybe power wall grade B because kat rumah smaller and can tolerate less. But for grid batteries yang besar-besar duduk dalam container tu, it could be grade C because they have so many more batteries, and failure rates on 1-2 battery is not going to really matter. So that's the sort of thing that we're talking about. So they're looking at, my guess is looking at the success rate of whatever they're doing right now in terms of automotive grade punya battery. So that's what they're looking at. So the battery itself is now bigger in size. So when the battery is bigger in size, kita tend to look at it and say, whoa, what about thermal management, right? So heat is going to be accumulated inside the battery, and it's going to be a lot more difficult to manage the thermal issues in the battery pack. Well, apparently they've solved the problem by making it tabless. Kalau dulu dia ada macam tab, now dia tabless. What it is that, okay, this battery, because yang kita tengok yang Tesla ni, dia bateri bulat. So if you imagine Swiss roll, cake yang gulung-gulung tu kan, atau jam roll tu. So jam roll tu kalau you imagine dekat dalam sekali, dia ada macam anode, and dekat ujung dia cathode. So one end anode, one end cathode. So dia roll benda tu, and and that's how you get the positive and negative sides lah. So now dia dah tak ada tabs tu. So the reason why the tabs make so much difference is because the tab design requires the electron to run from one end of the jelly roll to the other end of the jelly roll, and that's the distance to causes more heat build up and all sorts of other things. So with this one, because they tak ada tab, the distance of movement for the electron is smaller, and that probably helps a lot also with the charging and discharging, and also heat management, and also the size of it. Apparently, I dengar some of the industry experts cakap it also helps with thermal management because of how much heat they can pull off at the ends due to the size compared to the volume. So that is, of course, another fantastic feature lah. So then, in terms of that, the design of the battery, the tabless reduction, that gives them 14% reduction in terms of dia punya cost ataupun kilowatt hour per dollar reduction. And then they go into the manufacturing process. And this is where Tesla is getting rid of the wet solution. The wet part of the battery. Sekarang dia guna powder. So it's dry powder, there is no solvents to be dried off, therefore you don't need to have a large oven. And if you tengok any of the footage of the Gigafactory in Nevada tu, a large chunk of the Panasonic section is just drying oven. Because they need to dry off the solvents tadi, masa they lay down the jelly tu before nak, so they need to dry that off. Because why they use a solvent is because to make it mix it, to make it uniform, and then they need to lay it down. So now I don't know what new process they're doing. They're turning into powder first, and by turning into powder, then they just lay it straight onto the jam roll, and now they need to just get it the right thickness, the wet consistency, whatever it is that they need to do lah, and that helps to reduce the size of the factory because you don't need the oven. And Tesla kept talking about, or Elon kept talking about how to make the factory more space efficient. So he says that at the current situation, most factories, if you look at the volume of the factory, only 1 or 2% is being used for productive purposes. Conveyance is not productive. When you're moving things from one point to another, it's not productive. So the actual working part is productive, and that's only 1 to 2%. And they want to increase that to, I don't know what, 10%, whatever it is. But it's going to be a very different way of doing things. So these things are things that make Tesla different because they are not a legacy auto manufacturer. They're not a legacy manufacturer. They don't have any kind of technological baggage, and they're also the sort of company that are willing to make design changes continuously. You see something that's wrong, somebody tells them they can do better way, they just stop and just do something better. They don't have any kind of hang-ups to a traditional way of doing things, and then that is something that may be making them different from all the other car companies lah. And then that's 18% in terms of the reduction. And then the other thing is anode and cathode. And I tak faham like this about the actual raw material that they're going to be using in the battery lah. So also before we go there in terms of the battery chemistry, so it looks like they're going to have 3 different chemistry. One that is liquid lithium iron phosphate, LFP, F because ferrum, LFP. That is going to be apparently for certain application. Then they'll have a low nickel chemistry for a slightly different application, and then a high nickel chemistry into a different application. So the 3 different applications is simply basically capacity lah. So the lithium iron phosphate ni, dia has slightly less capacity, and therefore the battery has to be slightly heavier to achieve the same amount of capacity. For the low nickel battery, it has slightly higher capacity and therefore slightly lighter. And yang paling penting sekali, the high nickel battery, that is going to have the highest capacity, and that's going to be for applications where weight is very sensitive. Now, you might think that weight is sensitive in cars. Tak, weight is more sensitive in trucks sebenarnya. Sebab trucks have a very strict weight limit, and whatever weight limit tu total combine of the truck and the cargo. So if kat Malaysia kita ada weight limit of, I don't know, 40 tan ke, 50 tan ke, 60 tan ke, or whatever it is, or kira on axle weight. Axle load lah. Every axle maximum load dia berapa, whether it's 10 tons ke, 9 tons ke, 8 tons ke, for double tires, and berapa for single, I don't know, whatever it is. So you have to include everything into that. And therefore, for a truck, it's important this high mileage battery or high nickel battery, kerana it's because they need to drive long distances, especially for prime movers. So because Tesla is making the Tesla truck, and that's for the prime mover, and that's the articulated lorry. So that needs to have very high capacity battery to drive very long range, but it still has to be light enough to make sense for the truck driver. Okay. Then the slightly lower capacity battery maybe for cars ataupun maybe for larger sedans, and and then the heaviest battery maybe for cars that are more sensitive in terms of the price, because the lithium iron phosphate battery is more economical to build, and that is the battery that they're using in China, that they buy over from CATL untuk dia punya Model 3 production in China, if I'm not mistaken lah. So that's what it is that they're doing with the 3 different chemistry. In terms of the anode and cathode ni, it's about the material they want to use, whether it's silica ke apa, I tak sure sangat. But this, then the lithium, and they're talking about how they're going to process the actual raw materials, and apparently they've got some really funky process that is really simplifying, not using acid extraction, using saline extraction, basically guna garam to extract the materials, and then it requires a lot less processing before it's converted into powder form to be laid into the battery. So that adds up to about 17% in terms of savings. So those savings is going to make it, of course, interesting. And also, to go back to the battery design, because the battery is bigger and has better thermal management, it's probably likely that they'll be able to charge faster. So everybody, one of the big disappointment of this Tesla battery day apparently is because he didn't say anything about the million-mile battery. And then bila kita tengok all the review of this, because this is very technical, I tak faham, and I looked at Autoline Daily, they have a special episode on this, where they got 2 industry experts lah, Sandy Monroe and Bob. And it's a battery expert like that, the guy. And the battery guy cakap, apa tu, the million-mile battery it already exists. So what it means, a million-mile battery, is a battery that does not degrade over time with charging and recharging. And basically, if the charging range is small, the battery does not deteriorate. So they have a lead-acid battery, according to this guy, a lead-acid battery that has been charged and discharged like over 1 million times. It has not degraded, but the range of charge and discharge is just 2 to 3%. So let's say you have something that sits at about, I don't know, whatever is the sweet spot that they found, 57 to 57 to 60% or something like that. So they just keep charging it to 60, discharge to 57, charge balik to 60. So if your charge and discharge range is small, and then the battery does not degrade. So right now what we're looking at is 80% lah to 20%. So 80 to 20%. So basically you get, you don't want to charge the battery to full, if at all possible, because that is just putting a lot of pressure onto the battery. It's basically like cramming the balloon with a lot more air to give it potential. Of course, that causes stresses on the balloon and on the whole thing lah kan. And you don't want that. So basically, the battery, you charge maximum to 80% because that seems to be good enough. And you don't allow it to drop below 20%. So as long as you maintain between 20 to 80%, most car batteries now, I think, is good for a few 100,000 kilometers lah. At least for Tesla pun nampaknya macam tu. Dan recently Toyota pun announced 1 million kilometer battery. When I think that simply means that if you maintain that, the battery management system does not allow for charging and discharging between a range that's too big, then you can actually have it. So I think they already have it, and that's why they don't mention it, because I think it's already pre-existing, and because this, again, I think this briefing is not really for Joe Public. This briefing is really not for Wall Street. This briefing is actually for everybody else in the auto industry and everybody else in the battery industry. This is just Tesla telling them, we've cracked this. We're already building a pilot plan for it, and maybe in 2 years' time, 18 months to 30 to 24 months, we will get this out. And therefore, just have a heads up. And if you're already working on it, fine. Let's try to get there as quickly as possible. And if we get there as quickly as possible, then we'll already be able to offer all these electric cars at a much lower price, and then the market will actually open. And so okay, the last savings that they're gonna be able to achieve is how they design the cell, how they integrate it into the car. So now we might have seen the GigaPress. Basically, what the GigaPress is, a very large molding machine casting machine for aluminium. So the giga casting process is something that is very new. something so new that when I spoke to some German car executives pun, dia orang cakap they don't believe that it can really be done properly. But here we see that for Model Y, they dah gunakan this casting. So now the rear end of the car is one piece, the front end of the car is one piece. So in between, you still have stamped and welded parts, but front and rear is one piece cast aluminium. Now, casting ni is the cheapest way to form something sebenarnya. That is why kita tengok casting is the way for producing engines, whatever, because it's the easiest way and the cheapest way to form any kind of 3D object. And cuma the problem with casting is that the thermal issues, like when you cast something, there is the way that it cools down within the mold could cause any kind of problems in the structure of the metal, or the material could cause whatever problem, weaknesses, cracks, anything, and you have to really control that lah. So this one, I don't know how they've cracked it, but it is apparently a high pressure casting, and Tesla has developed a new aluminum alloy just for this, to allow it to be cast in one piece. So because these are front and rear ends of the car, they are they're structural, and also they bear most of the load and vibration from the wheels, from the engines, from the motors, from the road and everything. So it has to have some level of flexibility and yet be rigid enough to hold its form. Otherwise, then it doesn't make sense. And it has the flexibility is needed so that it doesn't crack. It has to be able to withstand a lot of small movements without metal fatigue. So that we don't know. Itu dia punya secret sauce, dia tak cerita lah apa dia punya actual composition of the new alloy, but that's what they've been able to do. So now, to further that, it seems that what they're going to do is now take the battery tray and turn that, bukan the battery tray, turn the battery structural. So the battery itself is going to be structural. So right now, kalau you tengok most electric cars, the battery is inside like a metal casing. And for many cars, that metal casing actually does contribute towards the structural strength of the car. So the battery pack is structural, but the battery inside is not, because the battery itself does not carry any kind of load. It's just inside the casing, and that casing has all sorts of bracing and whatever to make it rigid enough to hold the battery, because you tak nak ada movement or distortion inside. But right now, what Tesla is thinking of doing with the 4680 batteries is they're going to integrate the battery into the casing as structural members. So if you imagine macam Formula 1 cars, Formula 1 cars, they have outside carbon fiber skin, dalam ada aluminium honeycomb, and sebelah on the other side there is carbon fiber again. So the aluminium honeycomb kat dalam tu is actually contributing towards the shear strength of the whole thing. So then it becomes like a solid block of material. Better, because if you learn in school dulu, a solid rod of material is actually not as strong as a hollow pipe, because of the stresses semua is in actually the hollow part lah, in the void. So a lot of concentration of the stress is in the void. So kat situ the actual material is become stronger. So that's why kita tengok Formula 1 yang pakai this honeycomb structure, because the honeycomb structure allows the stresses to be distributed into the voids rather than the actual material itself. And this time around, what Tesla is doing, right now the batteries are inside the specs, whether they are cylindrical or prismatic or packets. The casing is structural, but the battery itself is not. Even with Tesla punya pun, because dalam tu dia ada fire retardant and all sorts of separators yang pakaikan liquid lah maybe, or macam foam kind of thing, or glue. But it looks like gel lah. So those things are not sticking the battery to the skin of the pack. But now they want to. It seems that they are developing, or already have developed, a way of making the retardant also a structural adhesive, so that the battery itself behaves like the aluminum honeycomb between the metal skins inside and out. And according to Elon, if this is implemented, then the structure of the car will be so rigid that you can actually basically build a convertible that is just as rigid as a car with a roof. So what is the implication of that? Satu, of course, I think the battery pack itself and that design will be slightly lighter, or maybe not, but same, or maybe the same weight. But the rigidity that it gives into the car will allow them to cut the weight on other parts. Yeah. So which means that, okay, what the floor pan basically is the hardest part to keep rigid, because the longest, the biggest part, the widest part, so it'll be flexing and all sort of thing. So when that is like completely rigid, so you can then now have a bit more maybe flex or whatever somewhere else, because you need a little bit of flex in the car to make it last, and for just general durability, and just for comfort. And also in terms of the structure, maybe they can make the roof structure lighter, the door structure lighter, because to be honest, the door structure does actually play a role in terms of keeping the car rigid. So if it's already so rigid, then maybe they could make the door slightly lighter and just design it for specific purpose. Rather than for rigidity, they may be able to just design the door for side intrusion mitigation, as in side impact lah. So you just design the door just for side impact mitigation, because you don't have to worry about rigidity, the doors contributing towards rigidity for the body, or maybe contributing less to the rigidity of the body. So I think that's where they're also showing that there will be savings in terms of the weight of a car is due to that lah. The way that the car is going to be built is going to make it a lot lighter. So here we look at the vehicle integration. There is 14% increase in range from vehicle integration. So that means there is a significant weight saving that they have achieved in the cell vehicle integration, when they're able to achieve 14% increase. We don't know how many percent weight loss that is being achieved here to achieve this 14% increase in terms of the vehicle body in white, or the whole vehicle weight. So that, when we're looking at that and we see, okay, these are really sebenarnya big numbers, huge numbers, and has implications later, because you have to remember that Tesla is more concerned about the machine that makes the machine. They are more concerned about the manufacturability of that thing, and how to design a manufacturing system or manufacturing process that is more efficient. To my mind, Tesla reminds me of Toyota in the old days. And today pun, Toyota still is very much focused into making the machine that makes the machine more efficient. The Toyota way, if everybody remembers, was all about that. And this is the Tesla way. In my mind, this is the Tesla way. He doesn't say it like that. I'm just saying it like that, because that's how it comes to my mind. So they're just focusing on making it easier to build the cars. So if you imagine just now the casting, that casting, the giga casting though, actually the impact for the giga casting is not so much on cars yang mahal. For cars like the Model S yang mahal-mahal tu, it's not going to be so big, because they're low volume cars. And these giga casting machines, they're huge machines, they're very expensive machines, and they are more suited for high volume cars. So they're building these factories not for the Model S. The Model S can continue to be built with stamped parts, and it still wouldn't make any difference, because the margin is so big in those cars. But when you're looking at building cars that are smaller and smaller and cheaper and more affordable, that's where you need to eke out every single percentage of cost advantage that you can get. And the giga casting that they're talking about and they're mentioning about in this battery day is going to be more suited. It's already being used in Model Y, and I'm sure it's going to be used in the Model 3 if it's not already been used. Because that's a more affordable car. But imagine a factory that needs to produce 300,000 cars. Okay, so it's as you could hear him saying, and in the battery production process dedicated, when you want building a factory, you want it to be running at highway speed everywhere. You don't want to have stop start, because in the factory right now, process there really is stop start lah, because especially in body assembly, because it has to move from station to station, because each station may have like 3, 4, 5 robots to do a certain number of operations, number of wells or whatever placing, and therefore then the habis process to stop, move to the next one, move, stop start. By doing whatever they're doing now for the front and rear end, they've reduced the number of parts from 375 to almost 400 parts to just 2. So that reduces the number of robots that's going to be needed for those 2 parts. So in in a factory, okay, here's the thing. You can build the same car with the less number of robots just by allowing the robots to do more things, one robot to do more things, but it'll take more time. So in order for you to build faster, you need more robots doing less things at every step. So you can make just pass, cepat. And that's how you speed up the production line speed, right? So now, by having the giga casting, you've already reduced the production, the stop-start. The thing goes out of the casting, it's already ready to go. Well, after cooling or whatever else that needs to be done, I don't know what the actual process is. But if you imagine, because that thing is, although it's a big machine, it has a much smaller footprint than that line of robots. So they are thinking ahead. They're already thinking about that $25,000 car, and all these things are designed for that. Although they mentioned just in passing the $25,000 car, I think everybody knows that that is where you need to be in order to make electric cars truly accessible to the public, truly to make it go below 20,000, between $15,000 to $20,000. That's where we're gonna find a lot of the buyers in the world for any kind of product. And for any kind of car. So kat Malaysia ni, for example, when we're looking at these electric cars, at the moment the electric cars starts to go about $75,000 to $125,000, ringgit, and then it becomes mass market, and everybody will be able to afford it. Especially when you take into account the fact that your operating costs will now become a lot lower, your maintenance costs is a lot lower, and it'll just make so much sense. So this battery day is basically Tesla telling the world that they are ready to go properly mass market in about 2.5 years' time. Are the other car companies prepared? So far, we see that Volkswagen is the most obvious, but I think all the other car companies are also very concerned. For example, companies like Mercedes-Benz, they've been spending a lot of money on electric cars, and they've been chalking up book losses because of the massive amount of investment that's going into their own electric series. Volkswagen also the same thing, and I'm quite sure BMW is also thinking about how they're going to handle this, although they're not saying it out loud, because these companies, they have a problem of legacy. They've invested so much, and they have a clear lead in internal combustion engine, and therefore they see Tesla as encroaching into their territory. And that's why they see Tesla as a threat. Whereas Tesla actually want them to get rid of their ICE and join this bandwagon so that the ICE becomes more interesting. So they don't see the rest of the auto industry as a threat. They see the rest of the auto industry as market builder that will help them build markets. Like they're downliner almost. So they just want more people to be doing electric cars so that electric cars become more commonplace. And because that's where they have the advantage, right? So that's how I see the Tesla battery day. So the footage hari ni mostly going to be just slides and something that I recovered from the presentation that Elon gave. So that's what it is. And there are two more things that has happened, but we're going to do this on maybe a later video today lah. Semalam, Geely announced that they are going to make their electric car platform open source. They're going to make their electric car platform open source. And by making it open source, they're doing it what Tesla did when they started building their architecture, by making it available to the public. But the difference is Geely says it's open source. What that means, I don't understand really, because I have not seen the legalese document. Later, I'm going to see somebody from Geely. We're going to talk a bit more in depth about that. But open source, in my mind, it's like Linux, it's like Android, where you can take whatever that you want and then develop that and then throw it back into the public. Because if it's open source, then you have to develop and share back. So I think Geely is also having the same mindset as Tesla, or developing that similar mindset where they want others to come in and help to speed up. So Tesla cerita benda ni, Tesla tells people what they're doing because they want to maybe get everybody to look up and say, okay, we have to push, because they're already pushing to accelerate the technological change. I'm sure all the other battery company are also doing the same thing that Tesla was thinking of doing, but now they just have to speed up. And Geely doing the same thing by offering it as open source. Then if other people develop parts of the thing, the platform, make it better, then it accelerates the development process, because no company is big enough to develop everything on their own, because this is a very disruptive technology. So by making it The way that Google saw that handphones or smartphones is a disruptive technology, and they decide to provide the backbone for it, Android. So now Geely and Tesla seems to be want to provide the backbones for this, and now Android is basically industry standard, right? So, and that's what we need, standardization, and that's what these two steps are going to help. So we'll do a little bit more on Geely. And finally, Volkswagen, of course, launched the ID.4. Now you have sort of a crossover electric car, fully electric car from Volkswagen, and the ID.3 and ID.4. So these are just big news on the electric front. And if you've been following my channel, you know that I've been pushing for electric cars in Malaysia, but we have not been able to make any kind of real headway. Maybe because the industry is not interested, industry is not ready, government is not interested, government is not ready. We don't know what it is, but we hope that this will change in the future. Okay, that's all that I have for this time around. If you've seen it to the end, I say thank you very much. And if you like it, please press the like button and share with your friends. Subscribe if you can, help me out. If you have subscribed, thank you very much. And press the bell button so that you get notifications the moment we upload a new video. By the way, I will do another video. Saya akan buat satu lagi video dalam bahasa Melayu untuk orang yang nak dengar dalam bahasa Melayu lah. So I understand this is I just me ranting quickly right now because I just don't have time to script it down in Malay. Saya akan buat satu dalam bahasa Melayu untuk the usual audience. And pemandu Malaysia, pemandu yang berhemah. Kita jumpa lagi, insyaAllah.